Well, good morning, everybody. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world, and no more so than this week. As many of our classes may know, live and on YouTube, we've been doing our deep dive into climate change. By the end of today, we will have done 22 broadcasts from, I think, 7 countries, over 5 days, featuring stories of everything from Arctic sea ice changing to coral reefs being affected by climate change, islands in the South Pacific disappearing under the waves, and we even went live to Norway to the amazing women of Hearts in the Ice at Bumsabu, the remote trapper's cabin in Svalbard. It's been a really exciting celebration, and thank you guys so much for joining us in the fun. So today we are joined by Chris Derksen, and he is a research scientist with the Climate Research Division of Environment and Climate Change Canada. They have been partnering with us all week with amazing stories from the field. And Chris today is going to talk about his adventures up to the Canadian Arctic, one of the most beautiful and remote places on this planet, for over 25 field expeditions to measure snow and ice, understand how climate change is impacting our north here in Canada. So Chris, without further ado, thank you so much for joining us, and take us away.
Great, Jesse. Thanks for the introduction. Thanks, everybody, for joining in today. Normally, of course, I like to do these sorts of presentations in person, where I bring a few props with me. So to get me in the mood and in the right spirit, I got my nice bright orange warm parka on my chair behind me. Usually I would let people maybe play around with my different hats that I have to keep myself, warm as I work through field work. And got these gloves with my convenient runny nose wiper on the back of them. So I have a few props here to help get me in the mood. Okay, so I'm going to talk to you a little bit today about my travels through the Arctic, measuring snow and ice. And really, I want to start off by saying thanks to all my traveling companions, all the people I've worked with and had the good fortune to travel across the Arctic with in recent decades. So I'm going to just... Does this sound better?
Yeah, that's actually a little bit clearer.
That sound worse.
You sound a little gravelier, but it's louder.
Okay, so maybe I'll go like this. I'm a bit bothered by these headphones today. Anyways, so so thanks to all my traveling companions, and I hope I can give you a flavor for the kind of work that I do. So next slide. How did I get interested in snow and ice? Well, I always enjoyed playing in the snow when I was a kid. I was fascinated by reading about explorers in the Arctic and the Antarctic. This is me as a youngster with one of my first attempts at what looks like a pretty bad snow fort, but I had a lot of fun playing in the snow as a kid. And luckily for me, my job has turned into something that allows me to keep playing in the snow. So I first went to the Arctic in 1994. Seems like a long time ago now. I look a little more wrinkly these days. I lived in that bright orange tent for 2 months with some good friends, and we had a really good time. It was my first experience making measurements across Arctic sea ice. And so those are just some photos of me in the field back in the day. And luckily, since 1994, I've had the good fortune to get back to the Arctic, different places in the Arctic, about 25 times. So what's my current job? Well, I work at Environment and Climate Change Canada. I'm based in Toronto, and I work with a team of people, and we use data from space, so satellite data, to monitor and tell us something about snow cover and sea ice in the Arctic and how that's changing over time. And then we use climate models to project forward in time and tell us how we can expect climate change to impact the Arctic in the decades ahead. For me, the most fun part, the most enjoyable part of my job is getting in the field and making measurements of snow and ice on the ground. And we have to do this. We make these measurements to ensure that we properly interpret the satellite data that we get from space. So this is a picture of me with some of my work colleagues from a couple of years ago at around 81 degrees near the Eureka weather station. I'm checking out some pretty interesting sea ice areas. So field work, getting out and exploring in the field, is the most enjoyable part of my job. And snow is that one aspect of the Arctic that I've focused on in recent decades. And snow is a really fascinating thing. It's a really interesting layer that exists on the Earth's surface. And it's important for a number of different reasons. Number one, when snow melts, it produces water. And we use that water for all sorts of different purposes. So it's a really important source of water for people around the planet. Snow is very bright, so it reflects a lot of sunlight in the Arctic back into space. So it's kind of like a thermostat. Arctic snow and sea ice is like a thermostat for our planet. Helps keep things a little bit cooler than it would be if we didn't have snow and sea ice. Snow is a really good insulator keeps the ground underneath the snowpack warm. And this is really helpful if you're a critter, an animal that lives in the snow. So lots of animals live in snow. A lot more animals actually live on top of snow. So polar bears live on snow and sea ice, for instance. Caribou interact directly with snow. So it's a really important part of the landscape in that regard as well. Now, we also know, and for those of you who live in snowy climates, you know that snow responds very quickly to warming temperatures. Snow, it needs to be below freezing for there to be snow. So with global warming, with climate change, as temperatures are increasing on our planet, it is decreasing the amount of time every year that we have snow on the ground. So snow is a really important part of our landscape, but it changes and can change very quickly because of climate change. And that's the kind of science that I do, is to study snow and understand how it's responding to climate change. For those of you in Canada, this is a Canada focus plot. It's an example of how our country has warmed since 1948, about 1.7 degrees Celsius. That's twice the rate of that the whole planet is warming. Northern regions, northern countries like Canada, are warming faster than the global average. And the northern part of Canada is warming even faster than the southern part of Canada. So that's the gray line on this plot shows the Canadian Arctic change in temperature. The red line shows the average for the whole planet. So we're seeing warming that's greater than the average as you move further north. And that really is in large part because of snow and sea ice. As we melt snow, as sea ice melts, it helps drive temperatures up even more. So it's really a concern. So this is some further context for the sort of work that I do. Now, I've been lucky enough to get out to the Arctic all across northern Canada. And again, we do this because we rely on data from satellites to tell us how snow in the Arctic is changing, how sea ice in the Arctic is changing. It's impossible to measure it on the ground everywhere. You need to have satellites to give us that broad perspective over what's happening. And then we make measurements in the field to make sure that we're interpreting that satellite data correctly. And so what I'll show you next are a whole series of photos that kind of go through some of these different experiences I've had in the field from all these different places. So from the Northwest Territories, a place called Trail Valley Creek, up north near Eureka on Ellesmere Island, Eastern Canada as well. So all these photos are come from these different experiences I've had measuring snow in all these different places across Canada. So I'll go through this in kind of a sequence. The first thing I'll do is tell you kind of how we live when we go up into the Arctic and we camp and we live on the land. And then I'll go through some of the measurements we make, some of the animals we see, that sort of thing. So sometimes we live in remote field camps. This is a place called Daring Lake in the Northwest Territories. We flew in on that single otter aircraft, and these tents are here permanently, but they don't always have people in them. We come up in the spring and we spend some time working out of that field camp. So you fly in and stay in a camp situation like this. Sometimes we take the camp with us. So that's an example of a camp that's always in the same place. But sometimes we can bring tents, we tow it behind a snowmobile, and we can set up a camp and move where we're measuring around from place to place. So this is an example of a trip I made with some colleagues from Alaska, where we drove snowmobiles across a large portion of the subarctic tundra. And every day we would move our camp to a different spot.
Oh, Chris, you've cut out for a second. Let's see if we can get you back. Oh, the perils of video broadcasting.
And when you're camping at night in the Arctic, you get to the moon actually, and I believe it was Venus is that bright planet that's off to the side there. So really, really neat visuals that you get to see when you're in the Arctic. Now, we'll look inside these tents. Well as a photo to capture some of those crowded conditions we have to deal with. We have to hang up our gear to dry every night because you kind of get warm and things get damp as you're working every day. You have to dry out your socks, your liners, and you have to have a place to sleep. So that's me on my cot on the right side. And if you sort of look on the bottom left corner, you can see the head of my friend who I work with, my colleague. So that's kind of gives you just a sense of what the living space looks like inside of our tent. So how do we travel? Well, snowmobiles are the main way that we travel across the Arctic. And so we can tow these sleds behind us that bring all the gear with us, the fuel that we need, the scientific instruments that we use, and sometimes camp. So this is going across a lake sometimes. So this is ice that's kind of come together. So you have to get a little bit creative in how you move your snowmobiles across this kind of landscape. This is a photo from near Ellesmere Island. You can see our snowmobile track there. We've been coming across the sea ice, making measurements of ice thickness. Sometimes we travel by helicopter. So this is a photo of a helicopter on a lake in Churchill, Manitoba. And this is a photo from Ellesmere Island. Again, just a scenic backdrop in the Arctic, traveling by helicopter to make it do when we're in the field. What sort of that is me walking across some Arctic tundra, holding a really ingenious instrument that looks kind of like a ski pole, but really it allows us to make automatic measurements of the snow depth. So I stick that probe in the snow. There's a little basket that moves up and down on it. It sits on top of the snow. I press a button, and magically it makes a measurement, and a GPS makes a location and tells me where I've made that measurement. So it really speeds up the process by which we can make measurements of how deep the snow is. We also make measurements of ice thickness. This helps us understand some of the measurements we get from space. It also helps us monitor how thick the ice is. As you can see, ice in the Arctic gets pretty thick. So that's standing on top of a snowmobile to get high enough off the ground to put that long auger into the ice. And on the right-hand side, so that's the same hole, just the beginning when we started to drill, and at the end when we punched through the ice into the water below. So you can see it's almost 2 meters of ice in this area. So it's a good chance to get warm if you're feeling cold is to auger a hole in 2 meters of ice. We look very closely at the structure of the snow. So we're not just interested in the snow depth, but we look at the actual snow grains themselves, how they're shaped, how they're layered, because this information within the snowpack actually does influence satellite measurements that we use. So it's not enough to just know how deep the snow is. We have to know a little bit about the structure of the snow as well. And that's me looking through a field microscope to get a closer look at some snow grains. Sometimes we put instruments on aircraft, so we can fly instruments that mimic the types of measurements we get from space, but we put them on an aircraft instead. And so that's just an example of an aircraft that we used for that purpose one time, kind of buzzing by close to where we had our camp set up. And this is a photo from an aircraft looking down at a big trench in the snow that we dug. So it's not always about making measurements just in one location, but we want to get a sense of how the snowpack varies from place to place. Now, I thought as interesting as the science is and the measurements are, I thought I should show you some slides of some of the interesting things that we see, the types of animals we see, and some other kind of fun stuff that has happened over the years. So these are Arctic birds called ptarmigan, that we see lots of those across the Arctic. These are the kind of prints that ptarmigan leave in the snow. There's always large groups of them together, so they make really interesting patterns and footprints in the snow. They are not afraid of humans at all. They're pretty bold, so they'll just sit there or stand there. You can get quite close to them and get some nice photos. These actually are footprints left on ice on top of a lake. So what happened was something walked across this lake when there was snow on top of it, compressed the snow, made the snow dense underneath those feet. And then when the wind came and blew the snow off the lake, it was able to keep those footprints there. So that's kind of a cool thing that we found one time. This is an Arctic hare. So we see lots of Arctic hare in the field. Sometimes their life is a bit stressful. So this is an Arctic hare being pursued by a gyrfalcon. We watched this play out over about 15 minutes, and I'm happy to report that the bunny did survive. It was not ever captured by the falcon. We see lots of caribou. That's a keystone species across the subarctic and the Arctic. And this is a wonderful photo that one of my Environment Canada colleagues took of a herd of muskox. Probably the most beautiful creatures, I think, in my opinion. Just a lot of character in those faces. And these muskox were living on Ellesmere Island, close to the Eureka weather station. Sometimes we see strange things. So one time I was digging a snow pit, and this little black spider came flying out of the snow. I have no idea. I'm not an expert in this. I have no idea what this thing was doing there, what kind of spider it was, but that was unexpected. On the right-hand side of this, you see some polar bear footprints. So we knew there was a polar bear around. That's one way you know there's bear activities by the footprints, but bears also leave their scat behind. So that's what we found in the middle here. So that's where we knew there was some bears around, because they left some deposits on the snow, which are pretty easy to see. We see lots of northern lights if we're lucky. So these are some photos from northern Quebec of some northern lights that one of my colleagues took. A couple of different photos. I always think that one looks like a cinnamon bun in the sky. And we had the very good fortune one year to have some Inuit elders camping with us, and they stayed in an igloo. That's their igloo, with some just beautiful northern lights behind it. Sometimes we see something called a sundog. So this is a colleague of mine who's using his head to block out the sun, so you don't see the actual sun that clearly, but you can see these sort of radial discs on both sides. And that's because when the atmosphere is very cold and there's ice crystals in the atmosphere, it will reflect the light from the sun and create this illusion that you have multiple suns in the sky. So you can sort of see almost 3 different suns from left to right across this photo. So these are pretty kind of rare, but pretty neat to see. Okay, so those are just some slides to show you some of the experiences I've had in the Arctic. I want us to get us thinking a little bit, some questions to think about when we think about snow. As I said, it's this really interesting material. Let's think a little bit about the properties of snow. So just some questions about when you walk in the snow, is it the same depth everywhere? Is snow a uniform blanket? It's not. So you can see in this photo here, you get really deep snow drifts forming in some places, meters and meters of snow. In some places, there's no snow at all. The ground is bare. So why is that? Well, snow moves around after it falls. And what makes snow move? It's the wind, right? The wind blows the snow, it shapes it on the landscape, creates some really interesting drift features, especially in the Arctic, because there's no trees and less vegetation to slow down the wind and trap the snow. So what makes the snow stop moving? Well, if the winds slow down, the snow stops moving. If there's slope, so the snow gets pushed over the ridge here and deposited into a big drift, shrubs, vegetation, all of these interact with snow to make these sort of complex patterns that we see on the land surface. Where's the ground warmer? Where's the ground colder? Well, as I mentioned earlier, snow is a really effective insulator. It keeps the soil beneath the snow much warmer than the air that's in the snow. So wherever the snow is deeper, you will have warmer soil beneath that. So there's an interplay between snow and soil. Something else to think about is when you dig into the snow, are snow crystals always the same shape? Well, we know that no 2 snowflakes are ever really alike, but we also know that the snow changes and evolves as you move from the top of the snow to the bottom of the snow. So in this picture, some of my colleagues are looking very closely at the layering in the snowpack along this trench. And the snow crystals change their shape through the season because the temperature in the snowpack is different. There's vapor that moves through the snowpack. So when snow sits on the ground, it doesn't stay static. It doesn't stay the same. It's evolving, changing its shape, creating different layers. So what looks kind of like a white blanket from above is really an interesting layered structure when you start to dig into it. So these are some zoomed in, really neat photos of different snow grains. And when you look through these 4 different photos of snow grains, can we think which of these is the newest snow and which of these is the oldest snow? And how do these snow crystals evolve and change during the season? So in the top left corner, you see kind of a classic snowflake shape of the 6 different arms of the snowflake. That's very fresh, young, new snow. Then as it gets a little bit old, as wind interacts with it, maybe the temperatures change a little bit, you can see that nice pristine shape of the snowflake start to break down a little bit. The edges get rounded off. Some of those arms of the snowflake break off. So you really get this decomposition. They tend to take on a more rounded shape. So all those nice arms of the snowflake disappear and you get these rounded snowflakes. Then if the snow lasts for many, many months, it can evolve into what's called burr. And that's these large grains shown on the left that actually take the shape of cups or flat plates. They take really interesting large shapes and they can grow to be the size of your. So these are quite large structures that form in the bottom of the snowpack, because that's the oldest snow, and it has evolved and metamorphosed, as call it, during snow season. Here is that snow does not fall and then stay the same and then melt in the spring. After snow falls, it moves around by the wind, it evolves, it changes its shape, it changes its structure. It's really, I think, a very fascinating process. So how about when snow melts? Does snow melt all at the same time? It doesn't. It obviously melts first where the snow is shallower. It melts on southern facing slopes first because that gets more direct sunlight. Slopes that face south get sun, and slopes that face north stay more in the shade. So during the spring in the Arctic, you get these really interesting patterns on the landscape where you start with, in the top left here, pretty completely snow-covered surface. And then over time, you see these ribbon shapes, the snow drifts. They stay on the land surface. The lakes are still snow and ice covered. Those are the larger white patches. And then if we move down to the right, the snow melt has progressed further. You still see some of these ribbon shapes on the land. And then bottom left, this is near the very end. And here you start to see only some snow and ice left on the lakes. And the land surface is pretty much free of snow. So snow melt is a very dynamic time period. A lot of different things are happening. And so it really creates these interesting patterns on the landscape. Okay, so I want to thank you for paying attention. And I just wanted to close with a couple of comments before I get to your questions. My sort of just comments as a scientist, as someone who's been really lucky to be able to study something that I really like to do. I like to play in the snow, so I've been really lucky to be able to turn that into part of my job. But even if you're not interested in snow, aren't too interested in the Arctic, my advice would be find something that interests you and go and do it. Pursue that interest, because when your job is something that you really enjoy, it really makes life a little easier, a little more pleasant when you can get some real passion out of your job. Obviously, sometimes there's trickier times to do this. And right now we're in a pandemic. It's a little bit harder. So we have to maybe get creative in how we pursue some of our passions. Maybe have to be a little bit patient, but hopefully, we'll move out of this and get into the times when we can move a bit more freely again. I haven't been able to go to the Arctic over the past year, but hopefully I'll get to go again in the future. And also I'll close by saying, don't be afraid to push yourself in new directions. That's part of exploring. That's part of seeing what life has in store for you. When I first went to the Arctic, I wasn't really an experienced person at camping. My family didn't camp a lot growing up. I was pretty nervous about what it'd be like to spend two months in a tent on sea ice in really cold weather. I had no experience doing that, but I had really good colleagues to work with who taught me how to do it. And I really grew to love it. So I think that's part of the lesson here. Don't be afraid to push yourself in new directions. You might like what you find. And finally, just for your teachers, some resources. There was a recent report that talked about the impact of climate change on the cryosphere. So that's snow and ice. It's a little technical. It's not great for moving the science into the classroom, but there recently was a climate education kit that was produced by a group in Europe. It's available for download at this website. And the objective of that program is to take sort of technical, jargony science that is still really interesting and translate it and provide some resources to help move that into the classroom. So if you're interested in cold regions and climate change and the impacts that has on the planet, that resource might be helpful, and you might want to consider checking out that website. Okay, that's the end of my slideshow. I went a bit longer than my planned 20 minutes, but I think we still have lots of time for questions. And
yeah, we sure do have tons of
Jesse,
time for questions.
Chris,
that was a fantastic presentation, man. So thank you so much for the images, the stories, and more. If you want to come out of screen share so you can see us again, a bit of a conversation, take your time to do that. While you're getting that ready, I'll just note for our groups joining in on YouTube only, share your questions in the chat bar. We'd love to hear where you're tuning in from, and we'll take as many questions as we can. We are going to start with a question from Miss Klein's groups. They're joining us in Santa Ana, California, grade 8 class. If you guys want to kick us off with a question, come on in. Hi, Miss Klein.
Hi, I'm going to share my screen, and let's see, I get the whole entire screen. And these are my amazing 6th, 7th, and 8th graders from the Advanced Learning Academy. We are in Santa Ana, California.
Yeah.
And so I'm trying to see if I can spotlight. It's kind of small. Oh, good. Now it's going to spotlight the speaker. So I'm going to stop talking and let amazing Luke Davis, he's one of our incredible 8th graders, ask his question.
Hey, Luke, welcome in, man.
Hi, I'm from Advanced Starting Academy. I'm wondering what would happen if you were to get lost in a blizzard and you can't figure out a way to get out?
That's a great question. So can you hear me now? I saw some comments that my mic was glitchy, but can you guys
so you're totally fine when you're good, and every now and then it'll just cut out for like a few seconds. So you're fine.
Okay.
If you ever do cut out mid-answer, I'll let you know, okay?
Yeah, okay. So that's our safety in the field is really important, and Arctic weather changes really quickly. So we have to always be prepared to know what to do when we're in that situation. And I will say things have changed a lot in the 25 years I've been going to the Arctic. Now we have GPSs, handheld global positioning systems, which are pretty cool because they'll have a map on it and I have an arrow that shows me exactly where I am and where my field camp is. So even if I can't see anything, I can just look down, and as long as the GPS is working and has battery power, then I'm good to go. In the old days, it wasn't quite that way. In the 1990s, we didn't have that technology, so you had to be much more careful. You had to set up maybe some markers on the sea ice and the snow to help you orient yourself where you are, because it gets deceptively difficult to navigate when it starts to snow, when it's cloudy, all that, the white horizon with the white snow, it all kind of looks the same. It's disorienting. So that's something we have to be really careful with. But nowadays, with the GPS systems we have, it's a lot easier.
Yeah. Cool question to kick us off. I don't think we've received that one in the entire series of programs so far, so thanks, man. I'm going to actually head to YouTube really quick, and then Miss Trempleasure and Miss Stubbs' class, you guys can get your questions ready. I know you guys are grade 11s and 10s. So Miss Mangat's class, they just want to know, what's the coldest temperature you've ever worked in? They're joining us in York Region, grade 5s.
That's a great question. I worked in Eureka one year. We got there, it was minus 45 Celsius. That's the coldest I've ever been. And I do pretty well in cold temperatures. I've had some little frostbite on my cheeks and stuff over the years, but let me tell you, in minus 45, we were working one day and I just didn't put my face covering on. So normally in those temperatures, you have to cover your whole face. And I thought, I'll just take my snowmobile like 100 meters and then I won't bother putting my face covering on to do that. That was a huge mistake. I froze the end of my nose. It was turned white and had a really strange look to it. And so I learned my lesson very clearly there, that was a very bad idea. So once it gets below minus 30 Celsius, that's when things kind of start to break and it's a bit difficult. Minus 40 and colder, it gets really, really challenging.
Yeah, it's funny you mentioned minus 30. Josh King, one of our other Environment Climate Change Canada scientists, mentioned that was sort of the benchmark temperature for like technology starting to fail en masse, which is really kind of neat. Our Californians today won't have any knowledge of negative 40, but us in Ontario here, when you throw water in the air, it freezes like instantly and comes down as ice, which is kind of a neat party trick. Let's head to our grade 11 environmental group. This is Miss Stubbs' class joining us down the road from us in Guelph. Just unmute your mic and you're good to go, guys. Here we go. Welcome in, everybody.
Hello, Jesse, Chris. I'll do a quick scan so everyone can say hi.
Hey, welcome in, guys.
And we have a question from Sam.
My question is, what are the trends you have noticed in the last 20 years with the snowpack and sea ice thickness?
Yeah, that's a great question, Sam. So what we're seeing is for sea ice, it's on the ocean for a lot shorter amount of time every year. So it melts earlier in the spring and it forms later in the fall. So that creates a lot of challenges because if you live in northern Canada, it means people there travel on the sea ice. It's how they move from place to place. It's how they hunt. So it really is creating challenges when we have these shorter time periods with sea ice. It's also opening up the Arctic to more ship traffic, for instance. So it's really changing access to the Arctic. It's changing how shipping companies can treat the Arctic. So that creates a lot of questions, right? Like, is it a good idea to be having more ships moving through the Arctic? What does that mean? So really it's this decrease in ice cover that's that is happening as a result of climate change. And the physics behind it, like the drivers for why it's happening, it's really quite clear that the climate change, warming temperatures, that's what's driving the changes we're seeing in sea ice. And it's the same thing for snow over land. It's melting earlier in the spring and it's falling later in the autumn.
I love these sort of questions. And I mean, all week long, of course, we've gotten to hear from people like you who have direct personal in the field experience of some of these amazing places in Northern Canada, across the globe. What I'd encourage all our classes to do, I've been harping on this again all week, is ask your teachers, ask your parents the differences that they've seen literally wherever you happen to be joining from in the world for climate change. I mean, when I was a kid, Toronto weather was very, very different than it is now. We had different wildlife that were here, so there's more animals coming northwards. We have different snowpack. I mean, it's March and it's 20 degrees outside. That's a very, very unusual situation. So it's again a nice opportunity to get that sort of direct climate change information from pretty much any adult in your life, and it's really special to get to hear from Chris today about his experience in the far north. I want to keep going down the 401. We were in Guelph. We're going to head to London to our Help Environmental Leaders, Miss Tran Pleasure's class. You guys have been sharing questions in the chat bar, but if you want to come in and ask in person, come on in. Hi, guys.
I don't know if you can see us. But
we can't see you, but we can hear you.
Oh, sorry. Okay, I've got Angelina here, and she's going to ask a question.
Hey, Angelina.
Hi, I was just wondering, when you were talking about like the actual complexity of the snow and how like detailed it is, do you notice any of the fine details of the snow being affected by climate change?
Yeah, that's an excellent question. And one thing that is changing a lot, not just in the Arctic, but in snowpacks everywhere, is that there's more dust particles that are falling into the snow. So, and this dust can travel in the atmosphere really long distances. So when you have a sandstorm event in the Sahara, for instance, that sand can end up being deposited in the snow in the Alps in France, for instance. And of course, snow, normally it's white, it's bright, so it reflects a lot of energy from the sun. If you deposit sand particles in the snow, all of a sudden you have this kind of browny, orangey looking snowpack. And I've seen some really weird photos from France, even from this past winter, where they had a few of these events happening. And what that means is that the snowpack melts earlier because it's able to absorb more heat from the sun because it's darker. It's not white. We always think of snow as being white, but actually that's not the case. And that's also a concern. I mentioned that there's more shipping activity going on in the Arctic. Well, ships emit pollution as they move through the Arctic. That soot is deposited into the snow, basically, which also changes the character, the nature of the snow. So all these things that are happening in the world, they do have an impact on the snow cover and the properties of the snow cover. That's a great question.
Yeah. I love that you looped in the Sahara element. It's still one of my favorite facts I've ever learned in science in my whole life, that like the Amazon rainforest is in part fertilized by the sands of the Sahara. That's so cool. I haven't heard about it in an Arctic context before, so that was really, really neat. Chris, we're going to take a few questions from YouTube, and then we'll go back for one more round with all our live classes. Ms. Leister's class, they're joining us in Dover, New Jersey. They want to know what type of food you eat on your trips. How are you preparing meals and whatnot?
Yeah, that's an excellent question. So I mentioned that one photo where we were camping with some Inuit elders, and we ate very well that trip because they were doing some fishing. They had some caribou with them, and so we were able to just they left the meat outside. It would freeze, and then you could just shave off pieces of raw fish, raw caribou, and they were very kind and shared their food with us. So that was the very interesting end of the spectrum. Otherwise, it's a little bit boring because really all we can do is boil water. So we eat a lot of rice and couscous and kind of basic things like that. Sometimes we work at places in the north that are part of a more formal research station. And in those places, there's often a cook who prepares meals for us. So like when we work at the Eureka Weather Station, we get very spoiled because there's a cook there and we can basically go and eat at the weather station. The best innovation that we ever had was our colleagues in Alaska designed this little thing that we could attach to the part of the engine of our snowmobile. And the heat from the snowmobile engine would warm up this little contraption. So in the morning, we would put frozen burritos inside this little metal box. And then we would spend the morning snowmobiling, doing our work. And perfectly around noon, those burritos would be warmed up and melty cheese, the whole deal. So that was really the most innovative use of cooking that I've seen in the field, where we were able to take our snowmobiles and use them to help warm up our food.
That is an amazing story. I love that. I hope you guys bought them bottles of champagne at the end of that. Let's head back to California. You've been sharing questions on YouTube, but come on in person. It's more fun this way. So, Miss Klein, go for it. Pick whichever one you'd like, and we'll go from there.
Great. Let me get the screen shared again.
Awesome. And then Miss Stubbs, we'll come to you guys next. I see you waiting there.
Good. And oh, good. Okay, so this time the question is going to be from another amazing 8th grader. His name is Andy. Let me feature his camera here. I'm getting good at this.
You are. Like at this point. Hey, Andy.
Hi, hello. My question for today is how much snow falls each year?
Yeah.
Oh, Andy, that's a great question. So that really depends on where you are. So more snow tends to fall in mountain areas of Western North America because all the moisture from over the ocean moves from west to east, hits the mountains, and falls there. So in cities like San Francisco, LA, the water supply for those cities comes from snow from the Sierra Nevadas, from the mountains. So mountain snow is often referred to as the water towers of the earth because they store all this water as snow and then it melts during the spring so we can use it. What's interesting is snow in January or February, about 45 million square kilometers of the earth is covered in snow. So that's kind of a hard number maybe to picture. It's a lot, right? So it covers a lot of the land surface. But then by July and August, there's virtually no snow. So it's one of these features of the landscape that goes through these naturally wild cycles from season to season. We go from having lots of snow to having almost no snow. So it just has this really interesting seasonal character to it that not many other parts of the earth kind of change as much as snow-covered areas do.
I love that you mentioned that. So in Josh King's presentation, which again on our YouTube playlist, you can check that out. There's a visualization of the breathing earth where you see the snow cover rise and fall over the seasons, and it's really amazing. So I encourage you guys to check that out. You also mentioned mountain snow. So few people have talked about this, but one thing I want all our classes to look at when they've done this program, in northern India, Pakistan, where climate change is affecting the amount of ice cover that there is and affecting people's water supply, there's a really creative solution that's fantastic. National Geographic's been covering this. They're called ice stupas. So this is people creating their own pockets of mountain ice and snow to draw upon for drinking water. Super, super cool climate change adaptation. And I'd encourage all you guys to check that out when you're done. Ms. Stubbs' class, we'll come back to you guys first, and we'll wrap up with Miss Tram Pleasure in a minute alongside a YouTube question. Come on in, guys.
Hello, we have a question from Paris.
Hi, I was just wondering if you've encountered any polar bears in your field work.
Polar bears, yeah, we have. So that first winter or first field season I spent in the Arctic, we actually had a polar bear wander into our camp at night and get a bit aggressive with one of our tents. Luckily, it didn't lead to anything negative, but bears are something that we have to be very conscious about when we're working in the Arctic. So we take some precautions, but the main thing is always be aware of your surroundings, and you know, we're definitely careful in that regard. We also have worked near Churchill, Manitoba. So those of you in Canada, Churchill is the polar bear capital of Canada. Tons of polar bears in that area. It's a really interesting place. But again, that's just adds a different element to our work. So it's something more to think about every day when you're working. So you always just have an eye up. And when someone has their head down in a snow pit, someone else who's working with you always has an eye to see what's happening around you.
We get the polar bear question every single program, and I'm really curious, Chris, do you get weapons training just in case as sort of a precaution when you go up to the north?
Yeah, we do. We carry shotguns with us, and we are trained obviously to use those. And of course, the goal is to never to have to use them. We have other non-lethal deterrents that we can use as well. So we are prepared. Thankfully, never had to use it in that situation, but we are prepared if we have to.
Yeah, I'm really glad we got that question. And by the way, grade 11s and grade 10s, you guys rock today. It's really rare to have so many enthusiastic kids that age asking questions, so I really appreciate it. So thanks, Paris, for our last one there. And I want to highlight for anyone who's keen on polar bears, Elisa McCall. She's at Polar Bears International. She's done a bevy of programs with us, so if you're keen on that, check out our YouTube channel. She is awesome if you want to learn more about sort of our elite land carnivore. Let's head to Miss Tram Pleasure's class, and then we'll wrap up with one from YouTube. Come on back in, help environmental leaders.
Hey, this is Maggie.
Hi.
Hi, I just had a question about what you would suggest for students who are interested in that line of field. Like, what would you recommend them doing for the future?
Yeah, that's an excellent question. And if you're interested in climate change, if you're interested in the Arctic, it's such a diverse topic. So I happen to focus on snow and satellite remote sensing and sea ice, but there's so many really important unanswered science questions that involve terrestrial ecosystems, permafrost. You can come at it from observations, you can come at it from modeling. So there really is, diverse pathways into the field. The main thing I think to do is to find like an education program that appeals to you for your undergraduate degree, and then you can specialize once you move beyond that. But I think the lesson here, the point is that there's not any one single pathway you have to take. It's really be driven by what motivates you. And I just see a question in the chat: is the field growing? I mean, it certainly is. I would say it is, both because the science of climate change is important, adaptation to climate change is important, climate change mitigation and policy making. There's so many different elements of this. If you have an interest in environmental law, you can come at it from that side. So there's really no boundaries, very few boundaries. It's more about finding that one area that engages you and moving forward that way. So maybe that's kind of an unsatisfactory answer because it's not that specific. But I think the fact that there is no one specific answer is actually the good part. There's some freedom here for people to pursue this in different ways.
Yeah, I love that question. And actually, that's a perfect answer. Maggie, it's funny. I was going to come to your question on YouTube next, so you beat me to it live. All along the sort of main Ontario corridor, whether it's London, Guelph, Waterloo, U of T, I mean, there's so many amazing universities doing programs and really starting to invest in this in a serious way. So if you are keen on this as a career, there are more options than ever. We've worked with scientists all week long and just in general that have their backdrops from those places. So do email us. I mean, exploringebtsoip@gmail.com, and I'll try and find some people who might be able to answer more questions directly and chat with you about this. It's really cool to have people that are keen on doing this as a career. Chris, this has been so much fun, man. I want to just share a few quick resources for our classes before we wrap up and say a big farewell, but time flies and you're having fun with these broadcasts. Chris shared at the end of his talk this link below. So, of course, HTTPS sort of thing, but check out that for some really cool resources. For some of our younger kids today, climatekids.ca is an initiative of Environment and Climate Change Canada. They've got some amazing resources. And if you guys would like to check out our full climate change list of programs, it's at our website here or on a YouTube playlist for our climate change deep dive. So many amazing programs. I really hope all our groups today get a chance to check it out. And so, Chris, what we do at the end of every broadcast, as you may know, I'm going to bring in all our teachers and groups today to say a quick thank you and goodbye. So, Miss Klein class, Miss
Cameron.
Class.
Yay.
Join me. Thank you so much, Chris.